Bismillahirrahmanirrahim. Welcome back to our series of demonstrations on how to create a library for character LCD in Cube MX IDE for STM32 series of microcontrollers. In our previous two demonstrations, we have laid the foundations for this library, and up till now we have been able to make a basic setup in which we can define the LCD pin connections, and then we can initialize the LCD, and then we can display various types of data, like we can display the uh, strings, we can display the integers, and we can write the floating point numbers. Just to recap our last demonstration, this was our Proteus program, and let me slightly zoom it so that we can see it properly. Right, so we can run it and we can see that we had printed 3.14, a floating point number, and that is being displayed on the LCD. Now let's progress further to position the cursor on a particular location on the LCD so that we can display the data at a particular location. So for that we need a function that should set the cursor position. The cursor position is set by by sending the address of the CG memory or data memory of the uh, LCD. The LCD memory is mapped in such a way that the first character of LCD is displayed from 0x80 position. Like if I show you here, this character, the very first character, this very first position, this is memory location 0x80. So if you add the columns to it, you get the cursor to that particular memory position, and each line has 20 characters in memory. Even if your display is 16 by 2 and it has 16 characters to display, but in memory it has 20 characters memory for every line. So the next line will be, after 20 characters, will be the third line. The second line will be uh, addressed from memory location 0x80 plus 20, and third line will be 0xC0. These are the various addresses you can find in the data sheet of your display, but these are fairly standard now. So to position on the zeroth line or zeroth row, 0x80 plus column, that is the position. And for line 1, 0xC0 plus column. For line 2, 0x80 plus 0x14, which is decimal 20, and then plus your particular column. And uh, for fourth line, 0xC0, same address, plus 14, which is 20, plus column. So in memory, the locations are in just one continuous array, a complete straight addresses. For lines, we have broken them into various positions. So since it is a command, so we have to set the RS pin to 0. So LCD RS pin is set to 0, and then you write this command, right? So you select this function. So if we have used this case switch and case command to for various positions, a row and column has been passed. So let's come up in our library, and in the end we write this function and we write the prototype of this function in the header file. This is header file, and here we write this function as prototype. Let's save it all. So when we want to set the cursor position, let's say if we want to display this number, and before this number we want LCD set cursor row. 0 is the first row and 1 is the second row, and column, let's say I want to place it on column number 16, semicolon, and then I display this character and this data. Build the project, and see, it is displayed here, and because of the long text, it has been wrapped to the next memory position, which is this line here. Right, so just to make it a little more plausible, %6 1.2f means that one character between 4 decimal point and 2 decimal places. You can read about these formats. These are standard C language formats for printf function. So here is 3.14 in the proper format. So our cursor position is set, right? Similarly, let's get rid of all this code, and we say the LCD set cursor row 0 column 0, and we display here LCD write LCD write let it be string LCD string, and we write only one letter A. We can use character as well to display the function, right? And then we use the same command here. So row 0 and column number 19, we display B, then row number 1, column 0, we display C, then row number 1 and column number 19, we display D. Let's see. And you can see this is the location for 0th column, this is 19th column, this is 0th column, this is 19th column, this is row 0, this is row 1, this is row 2, and this is row 3. So far it's good. Now let's come to some other LCD control functions, and these are to clear the LCD, to set the cursor off, set the cursor back on, set the cursor to blinking, set the cursor to home position, shift the LCD right by one character, shift the LCD whole on the left one character, turn the LCD off, LCD cursor shift one position left, LCD cursor shift one position right. These are all commands which are mentioned in the data sheet of your LCD. So we have defined these control characters, and we will use them by using the send command. Control C, we copy it, and uh, let's put them here. We can place them anywhere. These are the definitions. And to use these commands, we have to use the LCD command function. So let's say after writing this, we wait for some time, HAL underscore delay uh, 2 seconds, and then we want to clear the display. Then we choose LCD command, and for LCD command you can use LCD. These are the various constants, right? This is LCD clear and semicolon. If you hover over it, you will see this is 0x01. This is the beauty of this IDE, that whenever you hover over the variables or the macros, they will be expanded to show you the position. Like if you hover over here, it will show you the value of this definitions, right? So build project, and now our LCD should display some data, and then it should be cleared. So the data is displayed, and after 2 seconds LCD is clear and the cursor is positioned back at the home position. Similarly, if you want to set this cursor off, or you want to set the cursor to blinking, LCD, and let's say cursor blink, and then you write LCD string hello. So this will turn the LC cursor on as well and blinking as well. Build project. So first this data is displayed, the cursor is like this, and then the cursor is on, and hello is displayed and the cursor is blinking. Before that, if we want to clear the display, you can write the command LCD command LCD clear as well. So this will clear as well as show the cursor on. So this data is displayed, LCD clear, and now the cursor is blinking. And I hope we can combine the commands together in one go as well, that if I want to clear and LCD clear and OR it with the second command. Let's say comment out this line. LCD clear and LCD cursor blink. So both commands are sent in one. Let's see if it works. I hope it should. So this data is displayed. No, it didn't work. It is only setting one command. So you have to set the command separately. Anyway, that's fine. So here we complete our library. that now your library has all these commands and all these functions available to control the display, and all the library commands are present only in these two files. So this folder, you can just copy it and call it in another project. So let's see, okay, let's we stop it here, and stop it here, and we go to our folder where these commands have been placed. So LCD library 2, and this is the folder. We just copy it, and this folder is already here. We delete it. And copy, this is copy, and we paste it here. Right, so this is the folder. This contains both source files, LCD8C and LCD8H file. Now if we want to write a new, let's say, we close it, and we'll collapse all these libraries. Right, let's make a new project, file, new, STM32 project. And what is this? So STM32 F103 C8 T6. This library will work, by the way, for other controllers as well. And project name LCD test. Next, finish. Right, now we have to set our pin connections. Like in this case, we are going to have different connections. Right, let's say use PB0 to PB7. Right, PB0 GPIO output, PB1 GPIO output, PB2 GPIO output, PB2. Then where is PB3? This is PB3 GPIO output, PB4 GPI output PB5 as GPI output PB6, GPIO output PB7, GPIO output. So these will be for data, and PB, because we have to stay on the same port, PB12 as will be connected to RS, and PB13 will be connected to uh, I hope this is out of it little. Let's, so here are the connections, right? PB0, 1, 2, here are the connections, PB0, 1, 2, and then PB3, 4, 5, 6, and 7. These are for data, and PB12 and 13, these are for uh, register select and enable pins. So let's generate the code. Now we have also to reconfigure our this. Uh, this is PB12, PB12. This is PB13. This is PB0. This is PB1. This is PB2. This is PB3. This is PB4. This is PB5. This is PB6. And this is PB7. Right, and let me see if these have been mentioned here as well. Yes, they have been properly labeled. Right, let's save it. And now here we have to include that folder files. So one way is you can include the entire folder into your uh, uh, project, or you can just import those two files. So let's first try to import those two files. We go to the core, we go to the source folder, and here you import and import from the file system. Right, from folder, you choose the folder on desktop LCD8. So there are two files. You include the LCD C file and finish. So this file lcd8.c has been copied to the source folder. Similarly, in include folder, you have to import, right click, import file system. Next, you choose the same folder and include the hex file, H file. So this H file has been included here. Now in your main program, you have to include the H file only. So here you say hash include inverted commas lcd8.h. This file is included. Right, now you have to initialize the LCD. So we come to our main program, and in our main program, let's say after initializing all these things, we go to here. So LCD control space, and here is the setup. Port is GPIO-B. RS pin is G, GPIO underscore pin 12. I hope it's pin 12. Yes, pin 12. And enable is GPIO underscore pin 13. Similarly, this will be GPIO underscore pin 0. I just copy this thing and paste it here. And just paste it here, 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 paste, paste. And now we change the labels. Pin 0, this is pin 1, this is pin 2, this is pin 3, this is pin 4. These can be in any order. 5, pin 6, pin 7. And after that, there should be a semicolon. Right, then we have to initialize the LCD init, and no parameters are required. And now we can display on the LCD string hello, and that's it. Now, since we are going to use this program in our simulator, so we have to generate the hex file. So we go to the properties, build, settings, and post outputs, and convert to the hex file. Apply and close. Now we build the project. So project is built, and now in our program, first we have to change the hex file, debug, STM tutorials, LCD test, debug, and this is the LCD hex. Open, OK, and let's enlarge it and run it. And you can see the hello is displayed here. Now you don't have to worry about any internal functionality of the LCDs, etc. All you have to do is just to import these two files into the source and include folders. You can also include the entire library in a separate folder, but that is a separate issue. We have to set the paths as well, just like we did earlier, but it can work this way as well. So I hope you have enjoyed how to write an LCD display, device driver for your commands, and this is your library. You can share it with your friends, you can keep it in your folder and use it in various projects. since it is using the HAL libraries, and in none of the places we have not used any of the microcontroller specific registers. So if you change the microcontroller uh, in your project, like if you're using STM32 F407 or something like that, the library will work, hopefully, inshallah, because we have not used any controller specific commands. We have used that uh, HAL libraries. So this is how you make your own libraries for your own devices. And in our next videos, we will be making more libraries for more devices so that we have a good tool bag in our good tools of libraries in our bag so that we can write code for various projects. Then you don't have to reinvent the wheel. And I hope you can make your own libraries in this way. Do give us a feedback, and thank you very much. Stay blessed. Allah Hafiz.